Hey, welcome back. Today we're going to be doing LeetCode problem 70, climbing stairs. And today's solution is going to use something called dynamic programming. That's right, dynamic programming. This concept can be pretty hard to understand, so with that being said, let's do it together. And if you haven't already, like and subscribe to the channel, it really helps me out. Okay, let's get going. Let's go ahead and get started by reading the problem statement. You are climbing a staircase and it takes n steps to reach the top. Each time you can either climb 1 or 2 steps. In how many distinct ways can you climb to the top? For n is equal to 2, the output is 2 because there are 2 different ways to reach the top. 1 plus 1 or 2. For n is equal to 3, there are 3 different ways to reach the top, and our expected output is 3. 1 plus 1 plus 1, 1 plus 2, and 2 plus 1. Let's keep going with these examples. So for 4 stairs, there are 5 different ways to reach the top. 2 plus 2, 2 plus 1 plus 1, 1 plus 1 plus 2, 1 plus 2 plus 1, and 1 plus 1 plus 1 plus 1. And then for 5 stairs, there are 8 different ways to reach the top. Now, I'm not going to read all the 8 different ways to reach the top of 5 stairs, but you get the point. There are 8 different ways to reach the top. Okay, let's go ahead and dig a little bit deeper into this problem. Now, as you can tell, we have a bit of a subproblem, right? We're just continually adding to different stairs and we're adding all the different combinations. We can either climb 1 or 2 stairs, and essentially this boils down to a dynamic programming problem. Why? Well, dynamic programming problems always have subproblems, and that's how you know it's a dynamic programming problem. And this case specifically is a Fibonacci problem, right? If you're familiar with the Fibonacci sequence, it starts kind of like this: 1, 2, 3, 5, 8, and 13. What's the pattern? The pattern is, let's say I want this number 3. Well, I have to add up the previous 2 numbers, 1 plus 2, which is equal to 3. And if I want to reach 5, well, I have to add up the 2 previous numbers to that, 2 plus 3. 8, 3 plus 5. 13, 8 plus 5. Okay, great. So now we have a Fibonacci problem. We understand that. Let's dig a little bit deeper. What about these 2 staircase problems? 2 stairs is equal to 2 and 3 stairs is equal to 3. Well, I think it would be reasonable to say that if we have up to 3 stairs, we can just return n, right? Because it's the same amount of numbers. You can see here it says 1, 2, and 3. So 1 stair would be 1, 2 stair would be 2, and 3 stairs would be 3, right? So let's go ahead and take care of that first edge case. If n is less than or equal to 3, we're going to return n. Okay, what about the next problem? Well, in here, we're always adding the 2 previous numbers. How do we keep track of that? Well, let's go ahead and add in a new array called dp, and we're going to store those 2 previous numbers. What 2 previous numbers? Well, we're going to start with 2 and 3, right? Because we know that we can start at index 4 on the next go round. All the way, we have the number all the way up to 3, right? So we have all of this already. Let's go ahead and get started with this 4th one. So if n is greater than 3, then we're going to start on the 4th index. If that's the case, let's go ahead and start our for loop. And what we're going to do is we're going to iterate all the way up until n. So I is equal to 4. I is less than or equal to n, because we want to go all the way up to n. And we're going to say I plus plus. Okay, now we're going to create a temporary variable. We're going to say let temp equal dp of 0 plus dp of 1. And the next thing that we're going to do is we're going to say dp of 0 is equal to dp of 1. And then we're going to say dp of 1 is equal to temp. And then what we're going to do is we're going to return dp of 1. Why? So let's take a look at this. What we're doing is we're adding up these first 2 numbers, right? The previous 2 numbers, and then we're switching it. So we're saying 2 is now going to equal to 3, and 3 is actually going to equal to 5. So we're going to continue doing this all the way until we reach n. Let's go ahead and run this really quick. Okay, perfect. So we got all of our answers back. And let's take notice of our time complexity and our space complexity. Our time complexity at the moment is O of n, right? Because we're just looping through all the way up until n. But what about our space complexity? Well, our space complexity is currently O of n as well, right? Because we're continually adding to this array. How do we break this up? Well, we can kind of get rid of this dp. What I'm going to do is I'm going to say let num1 equal 2, and I'm going to say let num2 equal 3. So I'm going to get rid of this dp array. And now all of our dp stuff is going to be from these two variables. So I'm going to say num1 plus num2. And I'm going to say num1 plus is equal to num2. And I'm going to say num2 is equal to temp. And then we're just going to return num2 at the very end. So now instead of O of n space, we're going to always have O of constant space. Okay, let's go ahead and submit this. Okay, great. So it ran in 60 milliseconds and it took up only 41.82 megabytes. Alrighty, folks. With that being said, that's all I have for today. I hope you have a great day and a great rest of your week. And if you haven't already, subscribe to the channel. It really helps me out.